Hi, myself A.R. Ashwin from IARE Institute of Aeronautical Engineering. This is my course title Non-Homogeneous Differential Equation. Introduction of Introduction to non-homogeneous ODEs. Non-homogeneous ordinary differential equation. It is called ODE. Uh, as a form of L of y is equal to f of x, where L is a linear differential operators and f of x not equal to 0. Unlike homogeneous equation, non-homogeneous ODE includes an external focusing function f of x that drives the system dynamics. This equation model real-world systems such as forced vibration, electrical circuits with a voltage source, and a control system with inputs. Then general solution is composed of the complementary solution. So solution to homogeneous equation plus uh, particular solution to the non-homogeneous equation. Understanding non-homogeneous ODEs is essential in AIML for modeling dynamic system and time series data with external influence. Standard form and classification. The standard form of a linear non-homogeneous ODE of order n is a of n x by n plus so on a1 x y dash plus a naught x y is equal to f of x. The equation is linear if all coefficient ai x and f of x are function of x only and y, and its derivative appears linearly if all aix are constant. The equation is called linear with constant coefficient. Simplifying solution techniques. Non-homogeneous equations are classified by the nature of f of x, polymers, and exponential, trigonometric, or piecewise. In engineering applications such as circuit analyze f of x often represented in input signal like steps, impedance, or uh, insolute functions. Complementary and particular solutions. The general solution to a non-homogeneous ODE is y of x is equal to y dash c of x plus y dash p of x, where y dash c is the complementary solution. Y dash cx solves the solves uh, solve the associated homogeneous equation L of y is equal to 0 and contains arbitrary constant determined by internal condition. P of x is any specific solution that uh, satisfied the full non-homogeneous equation L of y is equal to f of x. The superposition principle applies if f of x is equal to f1x plus f2x, then y of p is equal to y of p1 plus y of p2 can be used. Finding y of c is involves solving the characteristics equation, while y of p depends on the forms on the form of f of x and method used. Method of undermining coefficient overview. The method of uh, undermined coefficient is used when f of x is polynomial exponential since cosines or combination theory of thereof. It assumes a form for y of p based on f of x with under undetermined coefficient to be solved by suit- into the ODE. If any terms in a assumed y of p is solution to the homogeneous equation, it must be multiplied by x or exponent to ensure independence. This method is efficient for coefficient constant coefficient ODE with a simple focusing function com- common in engineering students. It is widely used in modeling RLC circuit, mechanical vibration and control system response in AI driven automation. Under under undetermined coefficient example 1. Con- Consider y double dash minus 3 y dash plus 2y is equal to e encapsulation into 3x. The homogeneous solution is y dash c is equal to c1 e power encapsulation x plus c2 e power encapsulation into 2x. Since f of x is equal to e power x into 3x is not a solution to the homogeneous equation. Assume y of p is equal to a e encapsulation into 3x. Substitute y of p into the ODE. 9a minus 9a plus 2a into e power encapsulation into 3a is equal to e power encapsulation 3x give rise to 3a 2a into is equal to 1. A is equal to 1 by 2. Thus the equation there is a equation y of p is equal to 1 by 2 e power encapsulation into 3x. The general solution is y is equal to c1 e power encapsulation x plus c2 e power encapsulation into 2x plus 1 by 2 e power encapsulation 3x. This technique is computationally efficient and ideas for automates symbolic solves in AI based engineering tools. Undetermined coefficient example 2. Solved y double x plus y is equal to sin into x. The complementary solution is y dash c is equal to c1 cos x plus c2 sin x. Since sin x is equal is part of y dash c, the standard guess y of p is equal to a cos x plus b sin x failed due to duplication. Multiplied by x. Assume y of p is equal to x a cos x plus b sin x to ensure linear independence. Differential twice and substituted to solve for a and b while a is equal to 0, b is equal to minus 1 by 2. Final solution y is equal to c1 cos x plus c2 sin x minus x by 2 cos x, showing ratios in a undamped system. Variation of parameter concept. Variation of parameter is a general method applicable to any linear non-homogeneous ODE even with variable coefficient. It assumes the particular solution as a form y is equal y dash p is equal to u1 x by y1 x plus u2 x into y2 x, where y1 y2 are solution to the homogeneous equation. The function u1 and u2 are determined by solving a system derived from the Wronskian of y1 and y2. This method does not require f of x to have a specific form, making it more versatile than undetermined coefficient. It is essential for solving ODE, resting in arrow aeroelastic and control system where coefficient may vary with time or space. Variation of parametric formalization. Given y double dash plus px into y dash plus qx into y is equal to f of x with y1 y2 as a linearly independent solution of homogeneous equation. Assume y of p is equal to u1 y1 plus u2 y2 with constant u1 dash into y1 plus u2 dash into y2 is equal to 0 and u1 dash into y1 dash plus u2 dash into y2 dash is equal to f of x. Solve the solution. Given answer y1 y2 and y1 dash into y2 y2 dash u1 dash u2 dash is equal to 0 f of x using Cramer's rule. Variation of parametric example. Solve y double dash plus y is equal to tan x. Homogeneous solutions are y1 is equal to cos x, y2 is equal to sin x with Wronski w is equal to 1. Compute y1 dash is equal to minus sin x tan x is equal to minus sin square x by cos x and u1 u2 dash is equal to cos x tan x is equal to sin x. Integration. In integration we got final answer is sin x minus in sin x in secant x plus tan x u2 integration sin x dx minus is equal minus cos x, thus y of p is equal to sin x minus in secant x plus tan x cos x plus minus cos x sin x. Simplify. Y of p is equal to minus cos x into secant x plus tan x and general solution include this particular solution. Higher order non-homogeneous equation. For nth order linear non-homogeneous ODE, the solution structure remains y is equal to y dash c plus y dash p. The complementary solution y dash c involves n linearly independent solution form the characteristics equation. For constant coefficient, the characteristics equation may have real, complex or repeated roots efficiently via c dash form. Particular solutions can be found via undetermined coefficient or variance of parameter dependent on f of x. In AIML higher order ODE module, multiple layered dynamic systems such as robotics, motions or neutral differential equation. System of non-homogeneous ODE. System of the form x dash is equal to ax plus f of t arise in coupled mechanical, electrical and AI drives multiplier system. The general solution f dash c is equal to f of h t plus f x of pt, where xh solves x dash is equal to ax and x dash p is a particular solution. X dash h is found using 8 values and 8 vectors of matrix A, possible involving generalized 8 eigenvectors. X of p can be obtained via undermined coefficient for simple ft or vibration of parameter using the fundamental matrix. Such systems are fundamental in state space modeling for control theory and machine learning dynamics. Laplace transform method. Laplace transform concept linear ODE with concept coefficient into algebraic equation in the S domain. F of y double dash plus a of y dash plus b of y is equal to f of t. Applying Laplace field s square y of x plus sy into 0 y dash into 0 plus a in bracket s y of s minus y of g close bracket plus y of is equal to f of s. Solving for s of then the apply inverse Laplace transform to obtain y of t in operation internal condition directly. This method is a powerful for discontinuous or implies force focusing fundamental widely using a digital signal processing and control system within AIML application for real-time response analysis. Laplace transform example. This is an example. Solve y double x plus y 4y equal to alpha plus into pi y of p is equal to 0 y dash 0 is equal to 0 where alpha is a dynamic delta function. Application of engineering and AIML. Non-homogeneous ODE model forced vibration in aircraft wings essential for aerostatic stability analysis. In electrical engineering, there are described RLC circuit with AC source fundamental for filter designed in a single processing. With control theory they represent system response to external inputs, circuit for PID and state feedback controllers. In AML, they underline neutral ODE and continuous depth model where external data acts as a focusing function. Understanding this equation enabled the design of robust AI system for predictive maintenance and autonomous navigation. Numerical method of non-homogeneous ODE. When analyzed solutions are incredible, numerical methods like Urias, Rungas-Gupta or finite differential are employed. This method describes the ODE and approximative solution over time steps suitable for computer simulation for system with complex f of x or variance coefficient. Numerical appears provide partial solution. In AIML, numerical solution are increased into training loop for differential equation based model. Summary and key takeaway. Non-homogeneous ODE extend homogeneous model by incorporating external inputs essential for realistic system modeling. Solution method includes undetermined coefficient, vibration of parameters and Laplace transform each with specific applicability. The general solution combines complementary and particular solution reflecting system neutral and forced response. These equations are fundamentals in control system, signal processing and dynamic AI models in engineering. Mastery of these techniques enable computer science and AI students to design the analyze intelligent uh, responsive system. Thank you.